Welcome everybody to the third day of this 29th International Congress of Young Researchers in Zaragoza. I am Claudia Marín, President of ICIJA, and I will be connecting with you today. First of all, I would like to thank you, all of you who participated yesterday in the virtual escape room. We hope you enjoyed. On this third day of expositions, we will do the fourth and the fifth presentation sessions. So let's start connecting with our first speakers. So our first speakers of today are from Spain, are Cecilia and Alejandra, and they are going to present Perfumes Conciencia. There you go.
Hi, we are Cecilia and me, Alejandra. At the beginning of our project, we plan to carry out a work in which we could contribute to the improvement of our health and the environment. Our objective was not only to investigate, but also to experiment and put into practice the science analysis in order to create and defend our hypotheses and obtain results. We found the subject of perfume very interesting. We thought it was a very kind issue because of the number of people who use the perfume. We wanted to know what was behind the great commercial interest of the large perfume industry. We began to investigate the components of perfume with the idea of creating one in our project, and we were surprised by the amount of chemical and toxic components that made most of the perfume. We quickly investigated the consequences of these chemical components on people's health and after on the environment. We set some goals for our project. The result of the project has been positive. We have been able to accept our hypothesis, creating a range of liquid and natural perfumes using essential oils made by us, ensuring that they don't adversely affect our health and the environment. There are two key words in our project that have named our perfumes: aware of people to use natural perfumes taking benefit for our health and the environment, and knowledge that science has given us for its creation. Okay, our hypothesis, it is possible to obtain essential oils by using different techniques. The second hypothesis, it is possible to create liquid perfume with natural ingredients. It is possible to create solid perfume with natural ingredients. And young people don't use natural perfume. The method. The first method is the extraction process of natural essential oils. The distillation process, we use distillation water. The steps are: perforate tray with fruit or flower skin. Boil the water and raise the plant and skin. Mixture is evaporated and refrigerant system condensation. Essence recovered and the essence packaging. And the methylisation process, the first is cover rosemary with olive oil, warm at dark place, macerate for a month. We take from time to time. We strain with a paper filter and packing. And the second of maturation is for an essence. The steps are: let the fruit skin dry. We mix the skin and the glycerin. Take and let it rest in a dark and warm place. Take several times and strain the oil and pack. The second method is the produce for the production of natural liquid perfume. We use 10% natural essence, 5% vegetal glycerin, and 85% distilled water. And the last method is the produce to make natural solid perfume. The steps are: mix the sweet olive oil and essential oil, boil the mixture in a water bath, let rest, and finally put into reusable boxes. The result of initial question: when we buy a perfume, are we aware of whether it is natural or synthetic? We look it is aroma and don't the components. Let's get carried away my marketing. We aren't aware of chemical components of their effect. The second result is Why are the perfume industry investing of synthetic perfume? Is that the important thing is not the result, but the sale. They don't want to take risks. They bet on cheaper products, and they are interested in producing large quantities. Do we know the difference between natural and synthetic perfumes? The natural ingredients, they don't use preservatives and colorants, environmentally friendly extraction methods, no marketing companies, they are more expensive, recycled and reusable packaging. And synthetic, chemical synthesis ingredients, substances on animals, marketing companies, they don't recycle or reuse, they are cheaper. The result of the effort is how to know if a perfume has used natural and synthetic flavoring. The natural flavoring, they are produced with 10% natural raw materials. They don't suffer modifications. Its natural composition is specified on labels. They make perfume more expensive. The number 5, is there a legal provision against chemical ingredients? There are no European regulations, battle between different options, private certification companies guarantee the natural character of the perfume. The 6 is, what are the effects of chemical components on people's health? They could be allergies, respiratory diseases, migraine, change in mood, irritation of skin, altered system endocrine, breast cancer, obesity, infertility, and finally, the spots on skin. What are the effects of chemical components of the environment? Skin with chemical particles when we discover the richer river, solvent and peptide ingredients, gas emissions, peptides and extracts from lichen and danger, fish contain chemicals. And the last question is, what kind of consumers demand natural perfume? The result is people looking for products with less chemicals. People with allergies or sensitive to chemicals, and finally, those who follow a natural lifestyle. Okay, the results our hypothesis. I confirm my initial hypothesis. Obtain natural essence oil through the distillation and maturation process. Obtain liquid natural perfume with my natural essence. Obtain solid natural perfume with my natural essence, and the result of the survey. And we thank for the ICYR Association because he has given us the opportunity to explain now to all of you. And thanks. Bye.
Okay, girls. Thank you for your presentation. I'm sure that with this project will make people be concerned about using natural perfumes as they have benefits not only for health, also for the environment. We have no questions for you today. We are going to keep on with our presentations, and our next speakers are from South Africa. Thank you for your attention. Okay, so now our next speaker is from South Africa. He is Benjamin Stone, and he will introduce us about his project about future fuel. You can start.
Okay, my project is Future Fuel. The purpose of my project was the global climate crisis has resulted in an urgent need to find renewable sources of energy. My aim and hypothesis is to prove that you can make a renewable form of biogas out of speckworm. The miracle plant speckworm also known as the Portulacura afra. It is a carbon sponge. A specbourne thicket is 10 times more effective per hectare at carbon fixing than any other tropical rainforest. It is proudly South African. It is water-wise and can survive off 250 to 350 millimeters of water per year. It is easy to grow and it photosynthesizes at night too. And one of the most amazing things about it is it's edible and was used by one of the first settlers in South Africa, the San, to actually treat dehydration. So my method was I used 2 anaerobic digesters that were built using 2 25-liter bottles and a bicycle tube to capture the biogas produced. One digester was filled with kitchen waste and water, and the other one was filled with kitchen waste, specbourne, crushed specbourne, and water. The anaerobic digesters were observed for 21 days. This is a basic design of my digester. It's a little basic and it doesn't have all the detail, but there will be some pictures of the real digester just now. This is building the anaerobic digesters. So the first one on the left was loading the kitchen waste. As you can see, it's taped up on the top because it smelled really bad. The next one was filling the specbourne digester. This one was really easy and actually pretty fun, really fun to make. On the right, on the next slide, this is building the digester, which is drilling the holes. My dad wouldn't let me use his drill, so you can see him drilling the hole. And last one is loaded and ready, so ready to produce gas. This is preparing the specbourne. It looked like pesto, didn't taste like it, but anyway. This is my 21-day observation period. It took all the hottest periods and hottest temperatures from the 21 days. You can see that the hottest temperature was 30 degrees, while the lowest temperature was 3 degrees, which doesn't show on the graph, but it got really cold because during June and July is our winter, so we didn't have a sustained heat source. As you can see, we did get gas. We actually got gas. The anaerobic digesters produce gas to visibly fill the tube. As you can see on the right is the vegetable waste, the kitchen waste. And on the left is the specbourne. You can see that it's a lot more filled. And this left one is a lot more in the tube. And we did have some problems that my cat lay on the tubes and actually deflated the tubes, but she was cute, so it didn't really matter. And my conclusion was that you can make biogas out of specbourne, and it did even produce at a faster rate than kitchen waste. It was really exciting that this actually could be the future of a new sustainable gas, a biogas that could actually power our homes. It's very exciting just to think that this could actually be a new source. But my project didn't work as well as I wanted it to. It didn't produce enough gas to my liking, but I think that the reason is that it didn't have a sustainable heat source. So it didn't have a constant heat where it could produce the gas. And on the last slide is just an idea that I want to build on my project. This is an idea with a heat source and a cleaner to clean the gas. As you can see, there's a feeding tube to the heat source, which heats the waste, and the gas outlet to the gas bubbler, which cleans the gas to the point where it's pure methane, where it bubbles through, and then the end of the gas to the burner. And that's it.
Okay, so thank you very much for your presentation. I have a question for you. Where this idea came from, I think it's supposed that you had because the urgent need to find renewable sources of energy, isn't it? But like, can you tell us more a bit?
The idea came from my brother. My brother did do a similar project, and he didn't really prove anything. He had an amazing project, and I really wanted to build off it and prove that you can make a biogas. And I was really interested in the plant, and I researched it, and I actually found out that maybe it could produce a gas. So I tested and see if the spectrum could make gas, and it did, and at an actually very fast rate.
Okay, great. Thank you very much. Now we are going to say hello to our next speaker that is also from South Africa. Okay, so I will introduce him in a bit. Bye. Thank you.
Thank you. Bye. Thank you.
So now our next speaker is also from South Africa, as I told you, and he will present a project called Topple-Free Candle.
Hello, my name is Nico Ranchard, and I am from grade junior school in Port Elizabeth, South Africa. Last year, I was in grade 6, and I came up with an idea to create a topple-free candle. In South Africa in 2018, there were 2.1 million shacks in South Africa. The main cause of shack fires is open flames, and this results in the death of many people. The use of candles is a source of light, and it's very common in shacks, but it's very prone to cause shack fires. I have a solution to stop a burning candle from toppling over and igniting the surrounding objects. My aim is to stop the suffering of many people who live in shacks and who become victims of shack fires. There are many alternatives to using open flames for lighting, heating, and cooking, which are much safer and potentially less costly than existing methods. I've developed a concept for a topple-free candle, as you can see here. I will compare it to other light sources which have open flames and use the ease of it being knocked over as a variable. My topple-free candle can be mass-produced at a low cost and then sold at an affordable price. It can become much safer to conventional candles and other open flame light sources. On average, 18% of the population in all the major metropolitan areas live in informal housing or shacks. Electricity has been provided to most of these shack dwellers by the municipalities, and it's used mainly for lights, as you can see the stats included. But when the free electricity runs out, people can't afford to buy the prepaid units, so they revert back to their open flame light sources such as paraffin lights and candles. Fire-related mortality in South Africa is higher than the rest of the world. The reasons for fires in shacks are made up as follows for 2018, as you can see the stats. The current fire prevention measures used in shacks are mainly intumescent paint, which is a type of fire-resistant paint. Another one is fire retardant paint, which is a coating on the paint which releases a flame dampening gas, and then it protects the surface from flames. Another one is smoke alarms, which are activated early by smoke rather than the heat or presence of flames. Here are 4 main sources of open flames in shacks. A paraffin lamp, which is one of the most common and costs around 90 Rand, which is quite cheap in South Africa. A paraffin stove is used to cook and it costs 180 Rand. An alcohol lamp is also used mainly for light and costs 130 Rand. And the candle, which is also used for light, but it's very prone for toppling because it's short, is around 18 Rand for about 6. My method is to use my top-of-free candle compared to all of these open flame light sources. And they're mainly used alongside very flammable items like bedding, furniture, floor coverings, and clothes. And this is where I believe my candle can help. When I was little, I used a topple-free food bowl based on a gyroscopic frame to stop me from spilling food. I'm going to design this topple-free candle by converting the food bowl into a candle. My design in the future could be adopted and produced in aluminium or metal alloy to make it more affordable. I won't go into the definition of a gyroscope for now, but I will go further into my project. This bowl can be used as a holder for a candle, which would stop the flame from igniting surrounding objects. And this was my exact food bowl. The gyroscope design allows the bowl to remain level even if it falls. My prototype is the bowl with a candle inside it lined with aluminium foil to prevent the plastic from melting. And then eventually, if it gets mass produced, the frame could be made out of aluminium completely. Here are some 3D designs that I made before designing my actual prototype. My variables are the type of open flame light sources like candles, lamps, and my candle. And the constant variable is going to be the surface on which the candles stand and the amount of force used to knock over the candles or open flame light sources. And the dependent is obviously the results. These are some of the pictures of my variables that I used. In the water bottle, there is paraffin, and then to the right of that, it is a paraffin lamp. And then the next one is a smoke chimney that's used to put over the paraffin lamp to protect the flame. And then the next one is a pack of 6 candles. I found the candles to be very unstable and it can be knocked over quite easily because people use the wax to keep it upright. The candles are usually 20 to 25 centimeters, which increases the risk of it being knocked over, causing it to ignite other objects around it. When you're pouring the paraffin into the paraffin lamp, it started spilling, which can cause nearby items to become flammable and be prone to burning. It doesn't secure very well and it can be very unstable. And the chimney itself gets extremely hot eventually and can cause burns. And then as a reaction to the burn, you can knock over the candle. It's also very tall and breakable, which can lead to a spillage. It produces a lot of smoke, which can cause lung damage if you use it over a long time. The lamp is tall and fragile and has a high risk of it being accidentally knocked over and broken. My topple-free candle isn't very tall, which reduces the risk of it being knocked over by accident. The gyroscopic mechanism also leaves the flame remaining level. Here's an illustration of how my candle reacts to being knocked over. Here are some advantages from my topple-free candle compared to normal candles and open flame light sources. It's very short, which eliminates the risk of it being knocked over. When it's bumped, the mechanism allows the inner bowl to retain a level position. If it's completely knocked over, the inner bowl extinguishes the flame. And it does not contain flammable liquid, and it's not breakable because it's made out of plastic. It can also be refilled and reused by pouring more wax inside and making a homemade wick. My conclusion proved my results prove my hypothesis to be true. My candle's less likely to topple over and cause a fire than any other open flame light sources. I tested my bowl against a paraffin lamp and candles, and they only proved that those light sources were dangerous, but that they can be knocked over easily, causing a fire to start. It's also, my topple-free candle is not only less likely to be knocked over, but can also extinguish itself when it's completely toppled. If it's produced in an aluminium or metal alloy, it can be sustainable and withstand the harsh conditions of both weather and prolonged usage. In conclusion, this has been a very informative journey, and I hope to share with as many people as possible. I would like to thank my mom and my dad and my gardener, which all helped me with different aspects of my project. I hope you enjoyed my project. Thank you for listening.
Okay, thank you. That was great. Seeing how you made your prototype and the different results you went through were great. Thank you for your presentation. And now we will go to Brazil. So let me introduce the next speaker, and we are going to start with his presentation. So our next speaker is from Brazil, and he will present the project called Civic Watch Systems for Rich Watches from the Temperature Difference and the Thermoelectric Thin Films of Utilization. Thank you.
Hi everyone, my name is Vinicius. I'm from Brazil, specifically from Rio de Janeiro, so I'm in Carioca. Today I'm 18 years old, and my product is Civic Watch System for Wristwatches from Temperature Difference and Thermoelectric Thin Films Utilization. My advisor is Marco Vieira, co-advisor Michael Douglas Silva Santos, and I have a great important help that's from MetalMat, Engineering Institute of UFRJ, that involves material science and metallurgy. But probably you are asking ourselves, Vinicius, how the project started? And I answer you, Vinicius is a person who is very concerned with the environment. And when I discovered that 1% of total car around the world is from batteries in piles, I think, oh my god, I have to do something to change the situation. Because I use the device that mostly use these batteries, that's wristwatches. So I think too, that's 82% of people around the world, according to Cambridge, discard that on environment or in common garbage. That's a big problem. So I propose my goals that first is build a system for research from the elaboration of thermoelectric films in Brazil form, design its electronic circuit, ensure that circuit will be able to work in front of a little different temperature. 2. Enable the highest switch interval of batteries in the system and decrease the utilization of thermoelectric materials in big portion because we have a lack of all these materials. So that's the start of the product. So now that's the time to talk about the methodology, and first of all the reason to choose some material and methods. Then now we have the thermoelectric film, the bismuth filler based on antimony and selenium. They were chosen on account to the best results of the Seebeck constant and the figure of merit that ensure us the best results in room temperature of the application. And in conjunction to that, we have the flash deposition and the annealing. The flash deposition technique to deposit the material, and it was chosen on account to the cheap price of the application and the best result from all of the literature that have been read. And the annealing, of course, to improve all of the intrinsic results of these materials, such as thermoconductivity, electrical conductivity, Seebeck coefficient. We can manipulate everything with that. And the capital tape, of course, as a surface to deposit the material, but primarily as a form to load the thermal conductivity from the environment, to make the heat from, as in the summer, don't pass throughout the film. So make the external conditions don't matter in the situation. So to conclude everything, we have the heater based on copper and titanium to the thin film, primarily to keep the heat junctions warm. And that's the point. And now we can say about the electronic circuits. And first, the voltage converter LTC310A in conjunction to the transformer LPR 6235, because with that we can harness and transform 20 millivolts, just 20 millivolts, in 30 volts. That makes the application works. To the electronic circuit, we have the rechargeable battery from Seiko. That makes on sunny day, the circuit will continue to work on account of the battery being charged while the circuit is working. So that's a good resource to make the circuit working regardless of the situation, although the storm condition. So yet we can see the architecture of every thermoelectric film in the right side of the slide, and below the number of joints in every bracelet, varying of 165 millimeters to 196. So, to get the results of the thermoelectric film based on the calculus, I analyzed the literature from Takashiri 2008 and 2010 to analyze the grain thickness, electrical conductivity, seebeck coefficient, thermal conductivity, and the figure of merit to calculate the temporal range of operation, critical difference of temperature, electrical resistance of each semiconductor, and difference of electrical potential and current in function of temperature difference to analyze how everything will be increasing or decreasing. So with that, I could get the first results of the thermoelectric film based, of course, in my literature and comparing the intrinsic results of Takashiri 2008 and 10. But we have another point to follow in the design that will be concluding the methodology that is regarded to the simulation of the electric circuit in LT Spice. That's a virtual simulator of the circuit and the protoboard, of course, the operation of the whole circuit based on the tests taken, which were the charge distribution and alimentation of the circuit, and the correct output voltage and current in each component to, of course, analyze the drop voltage or the current, of course, and the charge and discharge time of the battery and durability. That's a good point to know how the circuits will be in every condition. Of course, that test was taken, and we'll see the results now. I'm so excited to show. So, with that, as you can see, first off, the thermoelectric film, the pre-results, you can see the range of sterile temperature of operation varying of each bracelet, of course, in 165 and 196, that basically the circuit will be working just between 33 and 37. The circuit will be working by the battery that was charged by the circuit which was working previously. So that's a good point to see, because it's seldom, so seldom. So difference too that varies 161 to 151. That's too small and difficult to recognize. So that's extremely good point of the project. And the best result, on my opinion, is the durability of the battery of the circuit, of course, that is between 129 years to 323 years. So that's too much. There is no human that survived for a long time. So the circuit will be the solution to this problem, that for the discard of the batteries in the environment. So with that, we don't have to discard. We can pass for all of the generations that are good. That's too extremely good to sound and to hear. And the electronic circuits is already done too, so the problem is solved. And the unique thing that is being doing too is the thermoelectric film in the lab to end off the analysis and the preparation with the flash deposition, as I have said before. And that sounds too much and extremely good. Steps continues, of course, as I have said before, the preparation of the thermoelectric film in the lab. And that's it. Thank you for watching the presentation, and it makes me so happy because the project changed my life. And with that, I have a phrase made by myself that is, science transformed my life. I don't say it in a cliche way, but yet as a speak of my intrinsic. So that's it. That's about Vinicius from Brazil, and thank you for watching.
Okay, great. So thank you for your presentation. We don't have any questions, so we are going back to connect with our next speakers. Thank you. Okay, so now we are going back with our presentation session. Now we have India presenting their project, and it's called Development of Innovative Smartphone-Based Pocket Microscope through Wireless System. So here you go.
Hello everyone, myself Jnani Raji Vinayakara Suryanshi. I'm from St. Xavier's High School, Kolhapur. My partner is Master Siddhant Raji Vinayakara Suryanshi. We are from India. So today I'm going to present my research project, that is development of innovative smartphone-based rotating pocket microscope through wireless connections. Technology has made education stress-free for both students and educators. A majority of Indians still lives in villages. Quality access to education is a major concern in rural areas, as there are fewer committed teachers, lack of proper instruments. Poverty is another setback. So I believe a solution is the only way to solve this problem at hand. And digital and technological solutions solves problem at digital space, or in most common case, the online space. So many teachers and school colleges have a large number of analog or ordinary microscopes. In developing countries, many resource limited setting microscopes having new technology are not available. The purpose microscope is constructed from a hardware component that can be easily found all over the world. Mobile phone microscope is created by adding magnifying optics of the smartphone camera's module. The purpose digital microscope has a magnification of 100x to 600x. The lenses made at laboratories is taken and inserted into the wings of rotating model, and the model is mounted in front of the camera. Our microscope is thus becomes ready for viewing. The specimen to be observed is kept under this microscope. Material used for construction are lenses specially prepared at laboratories, rotating model with multiple wings having variable lenses, accessories, just smartphone and other applications as per the availability. The total cost of this project is just $10. There are many merits, like it is best out of waste, low cost, portable, no maintenance, easy to operate, easy to handle, require less space, best solution for ready-made costly microscopes. We can use many microscopes with the help of this one. There are many lenses with variable magnification, which can be useful in this project. Study of practical and independently. The new innovative model has many wings with variable lenses having different magnification power. User can observe and study any microorganisms by using slides below this digital microscope. Even at home, the user can make the slides of any microorganism like algae, fungi, animal cell, plant cell, etc. User in different fields can study practically all the biological concepts very easily. The scientific principle. The lens used in my project is convex lens. It has principle that is convergence. When the rays of the light fall on this lens, it converges at a point that calls focal point. The distance between the optical center till the focal point is called focal length. Smaller the focal length, larger will be the image formed. My project, digital microscope, works on a principle that when a tiny object is placed within its focus, a virtual, erect, and magnified image is formed by the least distance of distinct vision of the eye held close to the lens. The importance of this arrangement is that the lens is being used as a magnifying glass. The magnification can range from 100 to 600x, with variable working distance ranging from 5.7 mm, depending on type of lenses for which we use. So this is a web diagram of the connections. As it is a digital microscope, it can be connected to many classes at the same time with a wireless connection through internet like Wi-Fi, hotspot, LAN network, WAN network, techno apps like DroidCam, IP webcam, smartphone, laptop, computer, projector with a single teacher. User can make this microscope. This user can also get the information of the same digital image aside to the digital side. We have also developed an app when the digital image is displayed on the projector or computer through a wireless system and techno apps. At the same time, the information of regarding that digital image is displayed on the screen. So not only for the biological uses, we can use this microscope for various analyses. Also as sand analysis, dirt analysis, skin analysis, hair analysis. Watchmakers can use to design watches, jewelry makers can use to design jewelries. We can use by prime specialists to see enlarged lines on a hand. It can be used for geologists, that can be used for geological surveys, skin specialists to find out various diseases of skin, cloth merchant to see the textures of cloth, farmers to see the soil particles, beauticians to identify skin problems, etc. It can also be used in research, education, medicine, in variety of biotechnological studies, industries, and many other trades and businesses. It can project real-time image of a slide under this microscope. Thank you.
Next project is from Mexico, so now we are going to connect with them. Thank you.
Thank you.
So now our next speakers are from Mexico, and they will present a project called Musabaj.
Hola, nosotras somos Daniela Flores Maximino, Ariana del Carmen Martínez Mayo y Diana Laura López Baños. Nosotras somos alumnas de la Facultad de Ciencias Agrícolas Campus Jalapa en la Universidad Veracruzana y estamos asesoradas por la doctora María Esther Díaz Martínez, quien es docente de la misma facultad. Nosotras desarrollamos el proyecto Musabaj, bolsas de papel plantable elaboradas a base de residuos agrícolas de banano. La producción y el consumo de plásticos han aumentado debido a su peso ligero, a su resistencia, durabilidad y bajos costos de producción. En los últimos años se han producido alrededor de 8.300 millones de toneladas de plásticos nuevos en el mundo, de los cuales alrededor del 9% se han reciclado, el 12% incinerado y la gran cantidad del 79% siguen en los basureros. En consecuencia de esto, se han generado grandes problemas de contaminación debido a que el consumo de estos productos tienen un tiempo de degradación de miles de años. Un ejemplo de estos productos son las bolsas de plástico, las cuales tienen una vida útil de aproximadamente 12 minutos y tardan en degradarse miles de años. Por otro lado, las actividades agrícolas también generan una gran cantidad de residuos, pero estos pueden ser aprovechados. Un claro ejemplo de estos son los residuos provenientes del cultivo del banano. En todo el mundo se producen más o menos 113.212.452 toneladas de plátano al año. México ocupa el 12º lugar a nivel mundial como productor de plátano y este es un producto tropical de gran importancia económica. En nuestro país se producen 2 millones de toneladas anuales y el estado de Veracruz produce el 60% de esta.
Durante su cultivo se realizan diferentes prácticas culturales, como lo son la poda de hojas, la poda de nuevos brotes y la eliminación del pseudotallo. Estos residuos se colocan como materia orgánica en el campo, pero en exceso puede aumentar las poblaciones de organismos dañinos para el cultivo. Por lo tanto, nos hicimos la siguiente pregunta: ¿qué valor agregado se le puede dar al residuo agrícola de banano para elaborar productos amigables con el ambiente? Siguiente.
No me deja cambiarla.
Realizamos una amplia revisión de la literatura y observamos que en la actualidad existe un resurgimiento de bolsas plásticas por la pandemia COVID-19 y por otro lado, un aumento del 60% en la demanda de papel para el embalaje de diversos productos. Así surgió la idea de dar uso a los residuos agrícolas de banano para elaborar bolsas de papel plantable que garanticen modalidades de consumo y producción sostenible como una alternativa para el uso de bolsas de plástico. Nuestro objetivo de este proyecto fue proporcionar una alternativa de bolsas de papel para el embalaje de diversos productos utilizados en la vida diaria, elaboradas a partir de fibras provenientes de residuos de pseudotallo de banano, que al final de su vida útil pueda ser plantable, así generando vida nueva y un cultivo sorpresa para el consumidor. Lo anterior nos permitirá invitar a la población a dejar atrás el consumo de bolsas de plástico. Al productor le permitirá innovar, darle un valor agregado a sus residuos y así también obtener un ingreso extra. El pseudotallo tiene características para elaborar papel que puede utilizarse en la fabricación de bolsas de embalaje. Para darnos respuesta a esta pregunta, realizamos dos metodologías que fueron libres de químicos. Para la elaboración de la primera metodología, realizamos la recolección del pseudotallo, la cual cortamos en pequeños trozos de aproximadamente 2,5 centímetros de ancho y se pasó por una cocción aproximadamente de 40 a 50 minutos. Se trituró en una licuadora. Con el método tradicional de papel, el cual consta de suspensión en agua y secado en tamiz, se obtuvieron los pliegos de papel. Después de algunas horas se colocaron semillas, en nuestro caso seleccionamos semillas de chía y se secaron durante 24 horas a la sombra. Se ensambló de manera manual y se pegó con pegamento realizado a base de fécula de maíz, agua, vinagre y sábila en diferentes proporciones.
En la segunda metodología, cortamos el pseudotallo en tiras de 10 centímetros por 60 centímetros de largo para obtener la fibra. Fue cortado manualmente, lo hervimos y la solución resultante se mezcló con sábila como aglutinante. Y con el método tradicional de papel, que es la suspensión en agua y el secado en tamiz, obtuvimos los pliegos y al final le adicionamos semillas. En ambos procesos realizamos un recubrimiento con fécula de maíz y vinagre para darle flexibilidad al papel y así poder elaborar la bolsa. Siguiente. En los resultados de la primera metodología se mostró un papel más claro, de textura gruesa, con resistencia a la penetración, pero con poca flexibilidad. Sin embargo, se permitió la elaboración de las bolsas. El tamaño de la fibra permitía cubrir las semillas de chía y la degradación de esta bolsa fue de 30 días. Siguiente, por favor. En la metodología 2 obtuvimos un papel de color más oscuro, con textura fina, con resistencia media a la penetración y una alta flexibilidad que permitía elaborar las bolsas con mayor facilidad. En esta bolsa se apreciaban las semillas en el adverso, pero también se podían ver las semillas si poníamos el papel al revés. La siguiente, por favor. Como conclusión, el residuo de pseudotallo de banano permite elaborar bolsas de papel plantable que al final de su vida útil genera un cultivo sorpresa para el consumidor. Muchas gracias.
Muchas gracias.
Thank you very much for your project. I have no questions for you, so we are going for our next speakers, okay, also from Mexico. And they will present the project that is called Conservación de la mariposa cuatro espejos. So I'm going to connect with them and then we will be back with you. Thank you. Hi everyone, we are back now with Mexico and the next project is Conservación de la mariposa cuatro espejos, Rochilía Cinta Cinta en el municipio de Angostura. You can start now. Thank you.
XXIX alei. Inapo, Génesis Victoria Jimena Aroscar. Entogne, Wotsmaniama. Woi, Wasuptiriangüe. Entogne secundaria. Adolfo López Mateoco. Inomaxtia, Imi Angosturaco. Mi nombre es Génesis Victoria Jimena Aroscar. Y las tres tenemos 12 años de edad y cursamos el primer grado de secundaria en la Escuela Secundaria General Federalizada Adolfo López Mateos, de la cabecera municipal de nuestro bello Angostura, Sinaloa, México.
XXIX Aleya. Inapo, Michelle Yoseli Mundaca Yanes. Hola, mi nombre es Michelle Yoseli Mundaca Yanes. XXIX Aleya. Inapo, Amenari Montoya Camacho. Hola, mi nombre es Amenari Montoya Camacho.
Nos presentamos en la lengua Gremnoco, porque nuestro proyecto Conservación de la mariposa cuatro espejos, Proxilia cinta cinta, en el municipio de Angostura, Sinaloa, México, está íntimamente relacionado con la cultura y la etnia yorimimayo, que habita en nuestro municipio de Angostura, Sinaloa, México. Siguiente, por favor. Este proyecto se realizó partiendo de la alerta amenazada para la mariposa cuatro espejos, Proxilia cinta cinta, de acuerdo a la norma 059 Semarnat, México 2010, y la importancia de esta especie para la preservación de la cultura y la etnia yoreme-mayo, así como sus danzas tradicionales autóctonas de nuestro municipio de Angostura, Sinaloa. Siguiente, por favor. Estudios recientes han demostrado que la mariposa cuatro espejos, Proxilia cinta cinta, ha disminuido su población a un grado alarmante. En virtud a esto, ha sido incluida desde el año 2019 en la norma 059 Semarnat, México 2010, en el estatus de especie amenazada. Siguiente, por favor.
La mariposa cuatro espejos, Proxilia cinta cinta, ha disminuido sus poblaciones drásticamente y se ha extinguido localmente alrededor de centros ceremoniales de los yoremes mayos.
Siguiente, por favor.
Los tinavares de capullo del lepidóptero, debido a su escasez y extinción natural, son sustituidos por capullos artificiales, construidos de envases PET, aluminio, cartón, mangueras, etc. Les llaman botenávares. Es urgente actuar para salvaguardar a esta especie y las tradiciones de la etnia yoreme-mayo, nativa del sur de Sonora, norte y centro de Sinaloa.
Por favor. Siguiente, por favor.
Hipótesis. La edificación y mantenimiento de un mariposario para la Proxilia cinta cinta en la Esperanza Angostura contribuirá a aumentar la población de la especie y librarla del estatus de amenazada. Objetivo general. Contribuirá a la recuperación y conservación de la mariposa cuatro espejos, Proxilia cinta cinta, en el municipio de Angostura, Sinaloa, México. Siguiente, por favor. Los bosques se están quedando sin animales. La mariposa cuatro espejos, Proxilia cinta cinta, es una especie clave culturalmente para grupos humanos tradicionales del noroeste de México. Los capullos de esta especie han desaparecido alrededor de centros ceremoniales y comunidades indígenas del norte de Sinaloa. Siguiente, por favor.
Amenazas a la especie. Recolección de capullos de manera no sustentable. Abuso de agroquímicos y plaguicidas en campos agrícolas. Sequías, ciclones, incendios, cambios climáticos y el uso del suelo. La Proxilia cinta Baisebori para los Yoreme Mayo, grupo étnico que habita en nuestro municipio de Angostura, ocupa un papel protagónico en su cosmovisión desde tiempos inmemoriales, al aportar sus capullos para la elaboración de los tenábares, parte fundamental del atuendo de sus danzantes de pascola y venado.
Siguiente, por favor. La metodología utilizada y el tipo de investigación fue la de estudios de casos, a través de investigación documental, de entrevistas y cuestionarios. La sumatoria de los 4 criterios del MED resultó... Siguiente, por favor. La sumatoria de los 4 criterios del MED resultó en 10 puntos como valor global. Con esta cuantificación, esta especie pasa a ser considerada como amenazada. El ANOM 059 Semarnat 2010, ya que los puntos para ubicar una especie en esta categoría son 10 y 11. Siguiente, por favor.
Nuestra hipótesis queda comprobada. Siguiente, por favor. Futuras líneas de investigación. Uso y manejo de capullos por los Yoremes Mayos. Impartición de talleres para la recolección y elaboración de tenábares de manera sostenible. Siguiente, por favor. Por lo anterior, se considera pertinente la instalación de un mariposario para la mariposa cuatro espejos, Rotzildia cinta cinta, así como una población de plantas agregado, Jatropa cinedea, especie hospedera por excelencia de dicho lepidóptero, en la comunidad de La Esperanza, Angostura, Sinaloa.
Siguiente, por favor. También este proyecto impactará localmente en la contribución al logro de los Objetivos de Desarrollo Sostenible de la ONU. Más específicamente en el 15, que a la letra dice, proteger, restablecer y promover el uso sostenible de los ecosistemas terrestres, efectuar una ordenación sostenible de los bosques, luchar contra la desertificación, detener y revertir la degradación de las tierras y poner freno a la pérdida de la diversidad biológica. Siguiente, por favor.
Pueblo que no danza, muere. La Rotzildia cinta cinta, Baisebori para los Yoreme Mayos, representa la continuidad de sus danzas tradicionales, ancestrales. Para que la mariposa cuatro espejos, Rotzildia cinta cinta, no deje de volar. Y los Yoreme Mayos no dejen de danzar. Yo creo que decía, muchas gracias.
Thank you, girls. That was amazing. And now, next project is from Tunisia. So I'm going to connect with them and then we will be back. Thank you very much.
Bye.
Bye.
Thank you. Bye. Thank you.
Okay, welcome again. We are solving some technical issues, but now we are back with our Spanish team. They are presenting their project. It's called CityFlow.
Hello everyone and welcome to our presentation. Today we are going to talk about CityFlow, our city mobility project. So let's get started. To begin with, we must explain the problems we have seen in our city and we want to solve. On the first chart, you can see the percent of people who use bikeways in different European cities. With our project, we want to improve their use. On the second chart appear the percent of Spanish people who live in big cities, regions, capitals. As you can see in these two charts, if we use the bikeways to move around the city, we could make the traffic flow smoother and we could reduce traffic jams. Hello everyone and welcome to our presentation. Today we are going to talk about City Flow, our city mobility project. So let's City Flow aims to bring better transport solutions through the city using the bikeway. COVID pandemic has shown how important e-commerce is nowadays. However, not all businesses can compete on equal terms. For instance, big companies such as Amazon or AliExpress have a developed distribution chain, while many small businesses don't have enough resources to send their product to consumers. With our project, small businesses would have the opportunity to compete with big companies, as they will have an autonomous and economical transport device, which will allow them to expand their market scope. Citizens could buy products on the internet from these stores anywhere in the city and receive them thanks to our service. Moreover, citizens with reduced mobility, like our elders, who have difficulties moving and being autonomous, could use our network to make their purchase in an easy way and without leaving their houses. If this project succeeds, it could not only allow freight traffic from small businesses, but also allow people, especially people with reduced mobility, to move easily around the city, being an individual, autonomous, and ecological transport. But that will be in a second phase of development. Hello,
So in this video, you can see how the app interface is, and the text is in Spanish, but we are going to explain it all. It is loading.
Guys, do you want me to present your video?
Well, if you had it, yes.
Yeah, I have your video from City Flow, the one that you sent me. So if it's that one, I can share our screen.
Okay, and can I talk while you are playing it?
Yeah, I think so.
Okay.
We will try to share our screen and present the video, and I will let you know if the video is okay and if you talk, if it's okay on the YouTube streaming, okay?
Okay, it's just to explain the video because it is in Spanish and we want all the people to understand what it is saying.
Okay, great. Yeah.
Tráficos, atascos, cuestas imposibles, calles con escaleras, vallas.
¿Te has parado a pensar alguna vez que nuestra ciudad no tiene una movilidad urbana eficiente y adaptada a todos los ciudadanos?
Esto nos afecta a todos.
Os presentamos nuestra solución, CityFlow. CityFlow consta de dos partes, una digital y otra física.
La digital sería un mapa donde grupos de voluntarios colocarían los obstáculos de la urbe. El mapa se encargaría de crear rutas personalizadas para evitarlos y además intentaría sincronizar todos los medios de transporte de manera que se evitasen los atascos.
La física consta de un dispositivo autónomo, como se puede ver en pantalla, que permitiría transportar personas y mercancías por la ciudad y que al igual que el resto de medios de transporte estaría conectado a la parte digital usando Internet de las cosas.
So, well, as you can have seen, there is a login screen. Then there is a tab with a map where you can see all the obstacles that there is in the city. And from this screen, you can ask for our physical service to transport something through the city. And the next tab is where people can mark obstacles and earn rewards by doing so. And finally, the settings tab. So we're going to the development part. We have made two prototypes, one on a small scale and the other in a full scale. As you can see, for the small scale, we have used for motors. I'm going to for motors connected to an L298N module. And this module is also connected to the Arduino board. And then there is an ultrasonic sensor to measure distances with the obstacles and a Bluetooth module to connect the prototype with an app. And we are going to explain all the problems, the challenges, which we have found during this process. The first one was the Bluetooth connection, because the Android documentation is very complete, but it is the same process. You have to try, fail, and try again, over and over again until it worked. So it is a difficult process. And the next challenge was the distance measurement with an ultrasonic sensor. The ultrasonics worked that they emit a wave. This wave bound with an obstacle and return, and the ultrasonic sensor measures the duration, and we multiply this duration by the speed of sound, and by this way we get the distance. And the next challenge was the follow the line, because different colors absorbs different quantities of light, and we use the difference between the white and the green color of the line way of the bike way to make our prototype to follow the line.
So here's the operation diagram of the car to avoid the obstacles. The car is always measuring the distance. If the measurement is lower than 30 centimeters, the car stops. It asks itself if it is the first time that the car stops. If it is the first time, it compares the distance to the right against the distance to the left. If the space on the right side is lower than the space on the left side, the car turns left and continues his path. And the opposite in the inverse case. However, if it isn't the first time that the car stops, it means that he is in a dead-end street. So the car will move backwards and repeat the process. So after developing and investing on a small prototype, we decided to invest in a full-scale prototype in order to improve the physical part. This vehicle has allowed us to upgrade Obo's design and function. We have learned a lot from this prototype, and we have to manage to build the vehicle using the less to implement it in the cheapest form. Now this prototype can transport wheelchairs. Its system is prepared to pick up reducing mobility passengers and carry them to their destination. Obo is in his test phase
telling us his solvable problems. We have found lots of obstacles during the evolution of the project, but we have been solving and we have been preserving and never lost our horizon. Each obstacle which didn't allow the project to grow up has encouraged us to deal with it. Both prototypes have been built from zero. Our project and ourselves have grown and are growing up as these prototypes do.
I think that everything was clear because I have no questions for you. So thank you for your presentation, and next group is going to be from Tunisia, and I will try to connect with them. Okay, so we are back with our presentation session. Now is the turn of Tunisian delegation, and they are going to present a project called Wave Species Controller. You can start.
The noise pollution happening with those motors running all the time. It's for something else as important as those. It's because of the random fishing happening in there. For a very long time, we've been so careless and harmful to sea creatures, and because of that today, our sea life is endangered and is slowly walking towards extinction. By 2048, it is predicted that we'll have no more sea life, since almost 70% of all fish types in the world are running towards extinction, knowing that almost 10% of them have already extinguished. And what pains me even more is that there is no law that forbids or tries to actually control or get rid of that random fishing. There is no law that tries to tell you, hey, you shouldn't catch the fish during a certain period because it might be its reproduction season. We should give it its time before thinking about it and making it our food again. We're over-exploiting in a greedy and unreasonable manner that is destroying our ecosystem overall. And since the ecosystem parts are all related together, and the fall or absence of one part may lead to the imbalance or even destruction of the whole organized system. And that's why, as humans, it is our first duty to take care of nature generally, and both fauna and flora specifically, not because of the moral code or some kind, but to protect humanity from ourselves and to preserve the humankind from destruction and extinction. And that's the main goal of our project. That's to help us organize our fishing exploitative activities with how much can the environment handle from it. And so we've come up with a solution.
According to our graphs, the major reason for fish extinction is actually fishing, as the fisher nowadays does not respect the reproduction cycle in fishes, which is considered as a threat to our marine fortunes. Also, actually, we asked people if they found a rare species, whether they would keep it or throw it back in water. And the results were 55% for keeping it, which may be a direct threat for this species to extinct, because people don't realize how this could affect all marine life. Well, obviously, the first thing we researched was the level of danger the sea life is truly facing, and the results were staggering. The reason why we are so determined to invent new methods in order to secure our precious sea life. We wanted to work on something that can affect fish in order to leave them swimming away from the boat, such as through either harmless chemical or light signals, electrical shock, or sound waves underwater. Then, later on, we discovered that fish has an amazing hearing capacity, as they are able to hear between 10 Hz and 10 kHz. So, as an efficient way to maintain the ecological balance and the continuity of marine life, we started working on this device, which is essentially made to avoid the random fishing by affecting the fish's behaviors through sound waves. And we're obliging the fishers to put this device in their boat, which will actually facilitate the procedures for us and definitely ensure fish production.
So as you can see here, we have this big problem, which is endangered fishes. After a lot of research, we've come out with this device for catching fishes using sound waves. Sound in general affects fish behavior, and especially slow frequency sounds a strange species. And we also know that every fish has its own hearing range. So after a lot of prototyping, we've come out of this with this prototype. So how it is gonna work? It's gonna start and make some tests to know which period of the year we're on, and also which place the boat is. So using this data, we're gonna this will go to the center unit, which will later know the frequency, and then using a frequency generator is gonna send this frequency. Also, as you can see here, this is our system. It's gonna be put under the boat, and it's gonna be related to the motherboard. So it's not gonna start unless it's only fully functional.
We conclude after our research that our device is finally able to help us from overfishing. It can attract or repulse fishes without putting the sea in danger, with showing us the type of fishes that we should catch at the place and the time we choose. As a future work, we think that we can place a touch sensor which will provide security to the device, as once someone or something disconnects our products from the boat, it will notify the host immediately, which will actually facilitate the procedure for us and definitely ensure fish protection. Thank you for your attention.
Thank you for your presentation. Your project was great and really interesting. I have no questions for you, so I think that the next group is also from Tunisia. So I'm going to connect with them and then we will be back. Thank you. Okay, so now we have our last group of today's sessions, and it's from Tunisia also, and they are going to present the project. It's called Turn On Green Energy and Free Food.
Thank you. Hello everyone, my name is Anna. I'm 15 years old. I'm a member in the Tunisian Association for the Future of Science and Technology, as well as the Tunisian Model of United Nations.
Hello, my name is Islam. I am 19 years old. I am also from Tunisia. I am in the Tunisian Association for the Future and for the Future of Science and Technology.
Hi, I'm Ahmed Mtawa. I'm 18 years old. I'm also from the association.
Hi, my name is Hassan Ben Said. I'm from Tunisia. I'm also a member of ATAST, the Tunisian Association for the Future of Science and Technology. So today we'll talk about affecting three huge aspects of our life as humans, which are air pollution, high cost of energy production, and homelessness. So entertainment, work, health, and basically everything that affects our daily activities revolves around electricity. But the procedure of creating that energy is causing air pollution, which is basically killing our planet. So also the cost of creating electricity is very expensive. As we see in the graph, the residential electricity cost has remarkably augmented through the latest years, and it's consuming a lot of material resources of all governments. Tawa, is there a problem?
Your mic is on.
Sorry. Also, the medium of homelessness in cities reached a frightening number, and we could make a really high impact if we could provide food or shelter for that minority. That's when we came with our idea. We found out that we can affect these three problems with our device, which will be installed in public areas for people in need to use in exchange for essentials. But that we would provide food and shelter for the homeless and create a low cost and environmental friendly energy.
The device is a vending machine that uses clean energy to charge batteries. All you have to do is to create an account using the small screen on the machine. Then you will be asked to make a specific amount of energy using the bicycle. When you provide the enough amount of energy, you can select the product you want. So you can find our project in all the public spaces like roads, metro or bus stations, gyms, schools. So our project went through different steps of making it. And during a test, we used an alternator to transform the kinetic energy you make using the bicycle into an electricity. And according to the test, we found out that we only produce a very small amount of energy, which is 0.6 watt. So we thought about adding a speed multiplicator, which will multiply the energy 18 times, as well as it's a recycled material. After some tests, we found that when you reach the maximum of speed in a minute, you produce 28,086 watt. So think about the amount of energy you can make in a whole year. It will be 246 watt, which is approximately a plasma.
To conclude, our project produce renewable and clear energy to reduce air pollution. Also help homeless by giving them food, tickets, whatever they want. In other side, it's healthy and useful for anyone can use it for all users because you're doing sport. And for the best thing for the users, it's cheap. It's very cheap. This project turn on has many achievements. The first one, he had the gold medal in IFEST, International Festival of Engineering and Science in Tunisia. He will has a patent in process very soon. He also have the government support and very soon the startup. Thank you for your attention.
Okay, thank you for your presentation. Now we have finished our presentation sessions for today. So thank you, everyone. Now you can go out from the Zoom, and we will tell the others about the last activity of today's session. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Okay, everyone, thank you very much for all your presentations. We have finished with the 5th presentation session for today. They were amazing, and you have told us that we learn something new every day. For today's activity, check your emails because we have sent you the link for a virtual tour of Zaragoza, and this way you will know a little bit more of our city for now from your screens, but we hope to see you soon next year. See you tomorrow in the last presentation session of the 29th International Congress of Young Researchers. Bye.